So first, if I asked you what the square root of 25 is, what would you say? It's 5. So 25 is what we call a perfect square number. And when I have a perfect square number, I can easily evaluate the square root either by using my brain like you guys just did, or you can take second x squared on your calculator, and you'll see above that x squared is our square root key function. So second x squared, and I type in 25 and I see, oh hey, it's 5. And that's my answer for that one. But what happens when our number is not a perfect square? On my calculator, I get square root of 45 is 6.708203932. Non-terminating, non-repeating decimal. Now, even though this is irrational, we can still simplify that square root. So what we want to do is make a factor tree for this out of square roots that includes a perfect square number and a non-perfect square number. So thinking about the perfect squares, which are listed in this chart over here, the right side is all perfect squares, and you will get this for the test. So, does 45 have a perfect square factor? 9 is a perfect square factor of 45. So I'm going to break this up into two factors, 9 and 5, where 9 is a perfect square and 5 is not. So folks, what is the square root of 9? It's 3. So then the 9 under the square root turns into 3. Can I do anything with the square root of 5? Nope, that's just going to say the square root of 5. So 3 rad 5, or 3 square root of 5, or 3 radical 5, is the simplified version of square root of 45. And if I type that in on my calculator, 3 square root of 5, notice that we get exactly the same non-terminating, non-repeating decimal. So just like 1/2 and 2/4 would both give me 0.5, but one of them is more simplified, one of them is better. 3 radical 5 is the simplified, better version of the square root of 45. So this is simplified, and this is what we want. Simplified. Now, the tricky thing about these is knowing that one of the factors has to be a perfect square in order for us to simplify this. For example, 15 and 3 also give me 45, but are either of those perfect squares? Nope. So this is a big sad face because they are not helpful in getting us to simplify the square root. Taking a look at square root of 40, any perfect square factors there? 4 we can take out. So I'm going to break it down into my perfect square factor and the non-perfect square factor. So I'm pretty much making a little factor tree out of square roots. So perfect square factor of 4 under the square root, what does that simplify to be? 2. So 2 rad 10. 2 radical 10 is my simplified answer. And folks, what's super duper about this is I can check and say, is the square root of 40 the same as 2 radical 10 or square root of 10? It sure is. Same non-terminating, non-repeating decimal. Now, 32. What's the biggest perfect square factor I can take out?
16.
Whoa, someone got it. So I'm impressed because when I look at 32, the only numbers I tend to think about are 4 and 8. So I want to show you that it's okay if you don't take out the biggest perfect square factor. It's just going to lead to a little bit more work down the road. So folks, if we did 4 and 8, 4 is a perfect square, 8 is not a perfect square. Square root of 4 is 2, and then square root of 8. The issue with this not being fully simplified is there are additional perfect squares we can take out of that square root. What's a perfect square factor of 8? 4. And the non-perfect square factor would be 2. So then 2 times square root of 4 is 2. Radical 2. And we get 4 radical 2. That's a lot of work. Whereas if we realize from the get-go that 16 is the biggest perfect square that we can take out, then 16 times 2 is 32, and the square root of 16 is 4. And 4 square root of 2. So you can do it this way and just keep taking out small perfect squares, but it's most efficient if you take out the biggest perfect square. So a good strategy, when I see 32, I'm not going to be able to divide that by 36. I'm not going to be able to divide it by 25. 16, I can try dividing that on my calculator, and you can just work your way down through those smaller and smaller perfect squares until you find the biggest one that works. So 192, it's big, it's nasty. It is an even number, so that kind of prompts me to try dividing it by 4. Ooh, and I get 48. Is there another perfect square I can take out of 48? 64. Another 4, which gives me 12. I can take another 4 out of that, and that gives me 3. So I took 4 out 3 times. So what's the biggest perfect square I can take out? 64. So this is what your calculator is for. This is what that list of perfect squares is for, because we want to try to find the biggest perfect square that I can take out of that square root. So 64 and 3. Square root of 64 is 8, comes out of the square root. And 3 is what is left over. Pew, 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 pew. And that is our simplified answer. What about 400? Now, if you're like, ooh, I can break that down into 104. Aren't 104 both perfect squares? So what does that tell me about the square root of 400? 400 itself is a perfect square. So 400, the square root of it would just be 20. So what about this one? Here we have square roots that already have coefficients out in front, so that 2 is just going to float in front with multiplication exactly as it's written. Any guesses as to what the perfect square we can take out of 125 is?
25.
25 is looking good. So that leaves me with square root of 25. That's the perfect square factor. Square root of 5 is the non-perfect square factor. And all of this stuff is joined by multiplication. It's literally just like a factor tree. So 2 times square root of 25 is 5. And that leaves me with radical 5. So 2 times 5 is 10. 10 radical 5 is my final simplified answer. On your own, see if you can do the last one. Anybody find the biggest perfect square we can take out? 64 didn't work, but it is even, so try some of those other even ones. 36. The other factor is 3. So 3 times square root of 36 is 6. Radical 3, square root of 3. 18 rad 3. Folks, have an amazing weekend. You are awesome. Thanks for all the factoring.
No, why? Because I got them yesterday and I threw them back.